All right. Well, welcome to week 3, guys. Lesson 4. How'd everyone do with everything?
Pretty good. I thought that the
Great.
concepts were pretty self-explanatory.
The concept was very
It was very
elementary. I would call it elementary at best.
Yeah, pretty basic.
yeah.
Anyone have any questions on the prep homework, on the prep?
No, that was pretty straightforward.
No, I was expecting it to be a lot harder than it really was, and it took me. That's
Yeah.
Yeah. It'll be interesting as the semester goes on. All right. The one I kind of went back and forth was no, I guess I got that one explained to myself though, about the what is it? The rule 3.
Oh, about the being
Oh,
no, that was
the
real
problem
too.
will not happen.
No,
Yeah, the
excuse me, not that one. There was the random.
Random variables, the discrete random variables.
Yeah,
Yeah.
discrete random variables.
That one just is it's a little more involved. You just have to make sure you get the formula right for each one for each instance.
Yeah. Okay.
Well, and I thought it was funny that in the description itself it said, "Oh well, the word discrete is actually too difficult for this class." So when I
yeah.
yeah.
All right, well, fine then.
yeah, sure.
Trust me, there's gonna be a lot more difficult. Well, at least for me, there's a lot more difficult things for my head than just this class. Just the word discrete.
Right.
I'm looking. Okay. So no questions.
Yeah, jump on and just do the group meeting quiz then.
Sounds like a plan.
Let's do it.
Okay.
13 questions.
Are we in lesson 4?
Yes.
We're
Yeah.
on lesson 4, week 3.
Hey, Brooke, it's good
Lesson-
to actually be able to hear you this time.
Yeah, it's because I didn't plug in my headphones.
Seriously?
That'll do it.
Yep.
That's weird.
All right. So question 3. Human blood can be classified into one of our basic types, O, A, B, and AB. The portion of the people in the population of the U.S. in the United States with each of these blood types is summarized in the following table. The blood type and proportion given in the table above is defined as a probability distribution. True?
What was the definition again of a probability distribution?
That it all equals 1, right?
So 15, yeah, so that all adds up to 1.
Yeah.
So true.
I
Okay.
think I'm not 100% on that one, but I think, yeah. What is the probability that a randomly selected person in the United States has O blood? Round to 2 decimals. 0.45.
Yep.
Is it that easy?
It's that easy.
All right. Well,
What is the probability that a randomly selected person will not have type O blood?
0.55?
0.55.
yeah. Does it need to be 0 point that, or could we just do like point?
You can just do
0.5.
point, but sometimes Island can be picky, so
I just think I had about a minute downtime right there. Where are you guys at?
Oh, did it freeze on you?
Yeah,
Okay, where were you at?
I left off. We were just on number 3.
number 3 is true. Number 4 is 0.45, and number 5 is 0.55.
Wait, hold on. It's my computer. I'm getting the spinning wheel of death right now.
Oh, shoot.
Number 3 was true. Number 4,
Right.
what did you,
0.45 for number 4.
okay.
And number 5 is 0.55.
I may lose you guys. It wants to
What kind of computer do you
kill
have?
or wait. It's a MacBook.
Oh, really? Huh. How old?
It's about 4 years old.
Oh, really? Yeah, because I have a 2011 thing, or no, 2013. So
Uh,
we'll keep you as long as we can, and then we'll.
2000. Okay.
So if anything, I don't know. Maybe cut the connection on your camera. See if that helps, and we can just hear you. And he froze again. Oh, there he is. Okay. All right. Who's got number 6?
I'll do number 6. Okay, so Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived with a bladder cancer patient. Tango, one of the dogs, demonstrates the identification of a specimen. 7 bowels containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Question 6. If the dog guesses at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
It's a 1 out of 6 chance. So what's the decimal of that?
So would it be 1 out of 7?
Or is it 1 out of
It would
7?
be 1 out of 7.
So it's
One cent.
0.142.
0.142.
Wait, so sorry, if we're rounding, it's 0.143. Sorry.
Round to 3 decimals before, yeah.
So 0.143,
Okay.
and that is 1 divided by 7.
Yeah. And I'll do question 7 as well. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, or there is little evidence that dogs can detect bladder cancer.
Well,
Vital.
I'd say it's strong evidence, isn't it?
Agreed.
It's
It's less
a
than
combined
half.
total of 54 trials. The dog correctly identified the specimen of cancer patients 22 times.
Oh, wait, but then that would be,
That's
So that's-
less than half. That's
That's less than
So
that's less
this
than
means-
half.
So this
So
right
then-
here means, so the probability of it, so it's a 1 out of 7 chance every time, which is 0.143. And in this case, if they got it 22 out of 54 times, they guessed it 40% of the time. So does it need to be greater than half?
I
Because
think.
it still is, it's significantly higher than the probability.
Well, I guess that's true.
But I don't know.
Yeah.
Was there anything in the reading that you guys remember about it needing to be a specific number?
No, there wasn't. I was just going back to the coin flipping thing where it really he's either right or they're wrong, right? In this
Right.
experiment.
Mm-hmm.
So it seems like if you have a 50% chance, you would but if there is nothing in it, I can't remember seeing anything that it has to be a minimum. If you're just taking a 1/7, then it is significantly higher than that.
Yeah, and the chances of getting it, 22 times right out of 54 trials, the probability of that is pretty impressive. I don't know how to do the math on it. So I don't know. My vote is for the strong evidence, but I could be wrong. I don't know.
Well, let's go with that, and then.
We can change it
And
if
then
we
if
need.
it's wrong, we can change it. Yeah.
yeah.
All right. All right.
I
who's got the-
can read number 8. M&M's
Go for it.
M&Ms are small chocolate candies. The M&M's website previously indicated that in the U.S., the distribution of the colors in a bag of plain M&Ms is given in the following tables. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy?
1/6 of whatever.
Or would it be,
Well, 0.13.
So for number 8, are we going with 0.13?
Oh, that's what it says. As the table says.
Yeah. I would agree.
Yeah.
What's the probability of selecting a green candy? Is
So I just did the
0.16.
math. It's 0.16.
.16.
The next one, and then 10 is 0.84.
Mike, you still cutting in and out? Or are you doing good now? I'm gonna take that as he's still cutting in and out.
Yeah. Oh, and is he the video connection cut off for you guys on him too?
I told him to cut it to see if that helped anything.
Oh, okay.
All right, then I'll do the next one. The ATC scores of students admitted in a medium-sized public university in the Western United States were taken from Captics.com. The following summary statistics were calculated. Half of the observations are less than or equal to what number? 24.
24.
Based on the information on the table, the top 25% of students scored what number?
27 or higher.
Yeah, it's above a 27.
27. What if the following statements is not one of the probability rules?
It's the third one. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. You cannot have a negative probability.
I
Right.
agree. Was that
All
you,
right.
Mike?
Yeah, I'm finally back.
Okay,
Right as we
which ones did you not get then, Mike?
I didn't get. I think it was 9. Was that 1/6?
Yeah, 9 is 0.16.
Okay, I'm just gonna write it down because it keeps freezing up on me. I can't even scroll down.
Oh, okay.
Might be time for an upgrade.
Hey, if you got the money to, why not?
I'll just write it down. Sorry.
That's fine.
So what number 10? What did you guys have for number 10?
Number 10, 0.84.
0.4. Then I had
0.84.
Oh, 0.84. And then I had 27 for 11.
24 for 11.
Oh.
And then
Question
27
12 is 27.
Right.
Oh, okay. And then 13 I had if the probability is higher.
Yeah.
I heard that one.
Yeah. Has anybody submitted yet?
Okay.
Not yet.
I'll go ahead and submit.
Sorry, I just hit it. So I guess we'll see here. That's 100%.
Cool.
Awesome.
Record time.
Sounds good, guys. Well,
Guys.
Okay.
I'll set up
All right. Yeah.
Thursday
Thanks
night.
for meeting.
Catch you
Good
guys.
night, guys.
Catch you guys on Thursday. Bye.
Yep.